Hey friends, welcome to error debugging. Today we are going to talk about ANSYS. What is ANSYS and what are the basic steps and some primitive steps in ANSYS which you can use in your primitive stages. So let's start. What is ANSYS? ANSYS is general purpose finite element analysis software package. Finite element analysis is a numerical method of deconstructing a complex system into very small pieces of user designated size called elements. The software implements equation that governs the behavior of these elements and solves them all, creating a comprehensive explanation of how the system acts as a whole. These results can be presented in tabulated or graphical forms. This type of analysis is typically used for design and optimization of systems far too complex to analyze by hand. Systems that may fit into this category are too complex due to their geometry scale or governing equations. ANSYS is standard finite element analysis teaching tool within the mechanical engineering department at many colleges. ANSYS is also used in civil and electrical engineering as well as the physics and chemistry departments. See friends, there are so many uses of ANSYS in modern day world. If you know this software, it will surely help you in your future. So let's start with some basic operations and let's try to understand them. Like I have taken a window here. I can cross it also, but I have to import a geometry from here, so I'll make a new window from here. Like we choose static structure for normal static structure. We just double click it and we'll get a new window here. As you can see friends, there are 7 things in this window: static structure, engineering data, geometry, model, setup, solution and results. So what the very first thing you do is you choose what kind of analysis you are going to perform. Like we are going to perform static structural analysis. We can perform so many different kind of analysis. As you can see here: modal, magnetic, IC engine, I converter, buckling, electric, explicit dynamics, anything, whatever is in the software. And when after that for the second point we choose engineering data. In engineering data we put the properties of material and we put the material. Like in my in my inbuilt data of this system, I've got only structural steel, and most of the static structures uh, are made by structural steel. So this is enough for static structure. But if you want to add some more engineering data, like more different materials, if your structure is of titanium or iron, simple iron, or anything cast iron, or any alloy or any polymer, you can just put those properties. You can add that material in here, and properties of that material you can add them in here. You can, like structural steel, you will have the values of density, isothermal expansion, thermal expansion, strain, tensile yield strength, compressive yield strength, shear yield strength, tensile ultimate strength, etc. Whatever options you have, just fill it, and units. And guys, the most important thing is, if you are in a different country, then you might have a different unit system. Like unit system, I have chosen metric system, but SI system is the most useful. You can use other systems like MKS and CGS, but here they have different names like US customary and US engineering. So you can use those system also. It's all on you, but you have to put exact units. You can't put a metric systems unit in MKS system or CGS system, as you know that. So now let's go back to our third option, and that is geometry. See guys, this is the geometry option. It is opening up, so let's talk about it. In this geometry option, you can make any geometry, or you can import any geometry from this, from here, from this option, like import external geometry file, and just make sure that those extensions are compatible with the Ansys software, or else they won't open. And if you just want to make a sketch, you can just make a simple sketch by clicking this option. That means look at face, that means the y-axis is up, x-axis is right, and z-axis is just coming to you. You can make anything, like if you make a circle, 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 you have a circle here, we choose the center, we make the circle. After making the circle, you can, in sketching part, when you are choosing a circle, you can adjust this radius, and obviously you would be knowing about sketching, so I should skip that part because it's so easy. And then we go to modeling, sketching. In modeling part, we generate the sketch that we have done. In modeling part, we're going to extrude it. The depth is 1 meter. Add material, operation is add material. Here we have two options, add material and add frozen. When you add frozen, the material will appear, but it will be like translucent, you can see through it. But we are going to choose add material because then it will be considered as one part, one body. Direction vector none liya hai, we have taken the direction vector none. Direction normal, okay, and depth 1 meter, okay. So and sketch is sketch 1, that is what we have made it in extrude, generate it. So now we have a disk, and now we are going to analyze it on Ansys. Basically it's not about the geometry, Ansys is more about analysis of the geometry. So here we are not going to learn about sketching, we are going to learn about how to perform analysis on those sketches. So we just minimize this window, so we can see that geometry part is also done. You can see a green tick over there. Then we go to the model. It's opening, so we have to wait. It's opening. See, this is the disk here. Okay, so the very first thing we are going to do, we are going to select the whole body. Why? Because we have to mesh, we have to generate mesh for the entire body. Okay, as you can see, there are this is the tree, the function tree, geometry, coordinate system, mesh, static structure, and we will see step by step what everything tells you. This is model, that means a model, and when this sign plus shows means that there are more options. Geometry, solid, coordinate system, okay, coordinate system, global coordinate system. Now you can see you can change your coordinate system according to you. I'm going to let them as it is. I'm going to mesh. I have to mesh this entire body. So I just, if you want to mesh in different size, if you want a different size nodes, you can go into sizing, and you can see the methods. Everything is there. You just have to explore it. What we are going to is generate mesh. See, the mesh is generated over here. See, these elements, these are the elements, and these are the nodes. Okay, so as you can see that these elements are quite big, but if you want smaller mesh, you want smaller elements, you can go into mesh control and you can control it accordingly. After meshing it, then we go to static structure, and that's what. And Here we are going to apply load and supports. Okay, so for support I'm going to choose the outer periphery of this solid. Okay, and we are going to apply a load through it, like uh, you will understand. I'm going to choose this option which selects the surfaces. So we have selected this surface for supports. So we are going to make this support as a fixed support. Okay, so this blue face is now fixed support, and then you go to loads in then you if you want to apply pressure, you can apply pressure. You want to apply hydrostatic pressure, you can apply hydrostatic pressure. You want to apply force, remote force, bearing load, anything, we are going to apply force. So for applying force we need a surface. Like for fixed support we have decided a surface, but for load we have to decide a surface, right? So we choose this box which gives us power to select a surface. Like I have selected this surface, and then I click apply. So on that geometry the force is going to be applied. The force, the magnitude, I have to give some magnitude. Like I am going to give it 1500 Newton. As it is force, it is going to be Newton. Its direction is this. We can change the direction by clicking these arrows. Okay, so now this is going that way. We are going to click apply and then we are going to click the solution. In solution information we have to solve. So when everything is done, when you have applied loads, when you have applied force, what you do next is solve. And when you click solve, it will take some time. The Ansys software will take some time to run some background mathematical expressions and equations to give the results about this geometry and how load is acting on it, and how the geometry is acting, and how the structural steel will act, and how the disk of structural steel will act under that force. So now here's the solution. In this solution, then we go to the results, deformation. Like I have to find the total deformation, so I will find deformation. We'll click solve. See, this is the total deformation. The blue part is very less stressed area, and the red part is most highly stressed area. And you can see each and every color is showing you how much stress is there. See, this is 5.5074 into 10 to the power 9 Newton per mm square. Maybe I don't know what the units are in here which are being input. So this is deformation. And if you want to see something else, like you can click solution, then you go to stress, and I will check equivalent von Mises stress. You click solve, and then you can see the von Mises stress, how this plate is going under the stress. And if you want to see the animation playing, you can see it, how it is bending with force acting on it. And then you minimize it. So see, and then you can see that all these options have a green tick against them. That shows that everything is done. See, in the modeler section we can see everything is done. Okay, so this is how you perform analysis, and by choosing these options like print preview, you can take out the report of that ANSYS. And this is report generation. So basically this is report generated on this type of steel and its model, and with having a force of 1500 Newton on it. So these are the basics of ANSYS. I hope you must have understand it. If there is any doubt, or if you want to ask me anything else, and if you don't like anything, you can tell me in the comments. Thank you for seeing this. Please like and subscribe.